Welcome back. In the last video, we have seen the change of variables formula for integrals of functions of a single variable. That is, we have seen this equation right here. We have this integral from a to b of f of x dx. That is, f of x is the integrand, and we are changing the variable from x to u via the function g, where g has an inverse function. That is, we are substituting x by g of u. Then the new integrand has two factors, where the first factor is obtained by substituting g of u for x in the original integrand, f, and then we have this extra factor g prime of u. And the new interval of integration from c to d is equal to the inverse of g applied to the original interval of integration. So if we apply g inverse to the interval from a to b, then we get the interval from c to d. So that's the new interval of integration here. So now recall that we asked the following question. We now want to look at the change of variables formula for double integrals. So let's say I have this double integral where the integrand is f of xy, and the region of integration is R. So we are taking the double integral of f of xy over the region R, and let's say we are changing variables from xy to uv via the function t, where t has an inverse function. So then if we do that, then what we want to ask is, what would be the new integrand and what's the new region of integration? So in other words, what we are doing is that we are substituting x and y with u and v via some function t. What that means is that x is a function of u and v, y is a function of u and v. So we are replacing x with some function of u and v, and we are replacing y with some function of u and v. And so if we do that, then the new integrand will have two factors, and the first factor is basically obtained by substituting x of uv and y of uv for x and y in the original integrand. And then we have this extra factor that we are going to see what that is. And then we need to also figure out what is the new region of integration. Well, so again, we are changing variables from xy to uv, and we need to know what is the new region of integration, and what would be the extra factor in our integrand. So d would be basically the inverse of t applied to the original region of integration. So d is t inverse of r, and in other words, t applied to d is equal to r, and the star here, the extra factor here, is the Jacobian of xy with respect to uv. So this is the symbol for the Jacobian, and the Jacobian is the determinant of the 2 by 2 matrix, where the first row, the entries in the first row are partials of x with respect to u and v, and the entries in the second row are partials of y with respect to u and v. Okay, so I'm going to stop here, and in the next video we will see an example.